Hello everyone, we're going to be going over how to do this stack-based application. Basically, it's an application where it's going to recognize Palindrome. And you'll see as we go through this that this is actually very simple to do after we get the base stack down. Just some things to note that we can ignore in the beginning. We need to ignore spaces, punctuation, and alpha characters, right? One other thing is that we don't want our program to push more than 25 characters, so we're going to have to restrict the user input there. So how I would start this is I would ignore all of this stuff in the beginning and add it at the end. What we really want to focus on here, even the palindromes, right? So what I really want to focus on is the stack-based, right? This is what we need. So let's get into this. We have our stack here. And, what is a stack? Let's go over how a stack works and what we want, what we're going to do here in this application. So imagine a stack as a bottom-up array, right? Here's our stack. Here's our little cells. And, the stack and the stack pointer, they work hand in hand, right? So when we initialize our stack pointer to 0, this is where we're starting, right? Because we're working bottom up. So what we want to do is we want to use a push function to push our variable or our value into the first cell, right? So let's go down here and let's look at my push function, right? Here it is, right here. We're adding a value to the stack, bottom down, bottom up. Sorry. So yeah, what we do is we take the stack and the index of the stack pointer, which you can see is right here, and we're just adding it. We're just setting it equal to the parameter value. Just go right there. So say that the value is A, right? We're putting in A here. And then we're adding 1 to the stack pointer. We're incrementing it by using ++, which means that we're moving the stack pointer up here. And this is our new stack pointer position, right? So we have the A, and we move, and it moves the stack pointer up 1 more cell. Okay, so say we add another one, we had another B. So we push B into the cell, move it up, and we have the pointer here, right? So now we want to get rid of the values, right? So basically what we're doing here is when we call pop, we're popping off the topmost value. So this is our pointer. Our pointer obviously is pointing to null because there's nothing in it. But when we call pop, we want the one right here. We want the one right underneath it. So we're getting the one at -1. Stack pointer -1. And that is our B in our diagram. We're setting the stack pointer, well, we're setting this value, which is stack pointer -1, to null. So now it's null. And now we're moving stack pointer down. So here's our stack pointer. Let me erase this. Let me make it a little cleaner here. So here's our stack pointer currently. And when we call pop, we're removing the B. Get the B out of here. We're moving down our stack. And then this is our new, this right here is our new pointer. So there's our new pointer. Then we just have A. Also, one thing to note is we also return the value when we pop it. So we're removing it and we're returning it. Okay. So now let's get into meat and potatoes of it, right? So what we want to do is we want to figure out if whatever we input is a palindrome. So here's our first couple lines. Here's our input variable right here. It's our simple char array of 25. This is all that we really need for the input, but the rest of this is to check if all of this right here, this is all to check if the user is greater, if the input is greater than 25. So let's run the program and see what I mean by this. So here's our program. So say I do A, B, C, D, E, F, G, H, I, J, whatever, right? If I go over the character amount, it'll say error and enter a phrase. But if I go and do a phrase that's under the character amount, it'll run it. And obviously ABC is not palindrome. More in depth on this while loop, the cin.fail, it returns true if your input is greater than 25, right? So if your input is greater than 25, this will return true, which means that this will repeat again. This will also make sure this will also return true because it's the same input. We see out error, we clear the cin, and we also clear the extra that was added on the end. So if you don't have ignore here, let's see what happens when you don't have ignore and you just use clear. So clear resets the fail bit, but ignore removes everything inside of your input. So without ignore, as you can see, if I add a bunch, it just messes up completely. Like it goes through it. It just says this is not a palindrome. Does not clear, or it does not ignore the extra bits on the end, right? It'll just use the extra bits on the end as the new input and use it and run the rest of the program. So we need that in our function or in our program. Okay, moving on. I decided to call two static character arrays, and one is going to be used for the reversed version of our input, and just the normal first version of our input that does not include characters or spaces or anything like that, right? So, like I said in the beginning, we do want to ignore character and spaces just to get the basics down. First off, we loop through stack. This is just because we know that there's 25 and that's a constant, so we can just put 25 in there. We're looping through all 25 in the stack. We're gonna check if the input is null, because when the input is null, thinking back to our stack diagram, which I removed, I shouldn't have. If it's null, there's nothing there, and that means that we're at the top of our stack and we don't want to read anything past that, so we just break and end, right? So yeah, we're checking if the input is a space. We're checking if there's punctuation. What isPunct does is it returns 0 if there's not punctuation and returns anything else there is. Like if it's a period, whatever the code for a period is will be what's returned of isPunct. So now that we have that and we know that there's no punctuation and there's no spaces, or it's not a space and it's not punctuation, we're going to add the lowercase of our input into the versed. Now, the reason that I'm using C here and not I is because say we have, I'm gonna type it in right next to the if statement. Say we have, I am cool, right? If we're looping through I am cool here, it'll go 1 or 0, 1, 2, including the space, right? But we don't want the space in our versed. So we need to make a separate counter. So it'll go 0, skip, 1, 2, skip, 3, 4, 5, 6. So that's how that works. And that's why we need a separate counter. And then we use our push function to push the input character at I, make it lowercase, and we push it into the stack. So now it's in the stack. Our loop will then finish as soon as the input is null, or the character at input I is null, which means that it's the end of the input, and we move on. once again, I need to use that C counter, set it back to 0. And now what we're doing is we're gonna pop through. We're gonna pop out every single variable, every single character that is in there. So now what we just did in that other loop is we just input our data completely in there. So I am cool, right? Whatever. So now each character is in our stack. This is where we are at right now when we reach this line, when we reach this while loop. This is where we're at. So now what we want to do is we want to pop the first value, right? The value off the top, which is going to be L in our case. We're popping it off, which means that it gets removed and our pointer gets moved down here. So we're popping that, and we're also checking here if there is if the value is an end of a line delimiter. We use this because in Visual Studio it returns an error, and you can get points off for having error or warnings, not an error. You could still run it if you didn't have this, but when I say that, I mean this. You could still run the program if you didn't have the delimiter character, but you will get a warning, and in some cases you get points off for the assignment, so you don't want to do that. Yeah, so we're checking that. If it's not that, we want to add the current value to the reverse string. So since we're popping off the top, right? This is the cool thing about stacks. We're popping off the top. We're actually getting the values backwards. So L, getting that. O, O, C, M, A, I. Okay, so yeah, that's how that works. So we're popping it off. So this is the whole while loop goes. This is how it works. We go through, pop off the L. We move the pointer down one. Then we're looping through it again. We're popping off the A. We're moving it down one. Once again, we're popping off the O. And we're popping off the O again, moving it down. We're popping off the C, moving it down. We're popping off the M, popping off the A. We're popping off the I. And every time we're moving it down, and we're taking that value and adding it into reverse every single time. So I am cool. Our reverse variable is actually going to be LOOCMAI, right? In all lowercase and no punctuation or spaces. Yeah, sorry about this terrible writing, but I get the gist of it. And that's it. And we just do a string compare right at the end after our while loop. We do a string compare. If reversed and versed 0, which means that they're equal, it is a palindrome. And if it's not, it is not a palindrome. Thank you guys. Have a good one.